everyone, thank you so much for clicking onto the video. Today we're going to be looking at reactions of alcohols, so here are our learning objectives. The first is to look at the combustion of alcohols and then the oxidation of alcohols by an oxidizing agent, and then the oxidation of primary alcohols to form aldehydes and carboxylic acids, and a control of the oxidation product using different reaction conditions, and then the oxidation of secondary alcohols to form ketones, and the resistance to oxidation of tertiary alcohols. We're then going to look at the elimination of water from alcohols in the presence of an acid catalyst and heat to form alkenes. And lastly, we'll be looking at the substitution with halide ions in the presence of acid to form haloalkanes. Now we're going to talk about the oxidation of alcohols. Alcohols can be oxidized in stages using acidified potassium dichromate or sodium dichromate. And primary alcohols are oxidized to aldehydes, which are then in turn oxidized to carboxylic acids. And secondary alcohols are oxidized to ketones. And tertiary alcohols are not easily oxidized, as it would involve breaking a carbon-carbon single bond, which takes a lot more energy than breaking a carbon-hydrogen bond. And this is also the reason why ketones are not oxidized any further. As a quick reminder about the different types of alcohols, a primary alcohol is one where the carbon which is attached to the hydroxide, so the OH, is only attached to one alkyl group. A secondary alcohol is where the carbon attached to the OH group is attached to two alkyl groups, and a tertiary alcohol is where the carbon which is attached to the OH is attached to three alkyl groups. And so this is why you can't oxidize the tertiary alcohols, because the carbon-carbon single bonds that we have take a lot more energy to break than the carbon-hydrogen bonds. So the first example we're going to look at is ethanol, which is a primary alcohol, and it's oxidized ethanol, which in turn is oxidized to ethanoic acid. So we start off with ethanol, which looks like this. So CH3, C, H, 2, and then OH. And then now we draw an arrow, and we use this symbol, so we use an O in square brackets to indicate that we're oxidizing. And so we label this oxidation. And the actual conditions we have it in is that the alcohol is in excess and there's no reflux. And we're going to be looking at reflux a little bit later. So we have an excess of alcohol and also no reflux. And then this will form the ethanol. So ethanol has this formula, so CH3, C, and then OH, like this. And so this is an aldehyde. So we started off with ethanol, and then now we've ended up with ethanol, which is the aldehyde. And then we can oxidize this even further using the square brackets O, and we label it oxidation. And this time we need the oxidizing agent in excess. And also we do have reflux this time. So this forms the ethanoic acid, which has a display formula of CH3, C, double bond O, OH. So this is our ethanoic acid. So the O with the square brackets indicates that we're oxidizing. However, we can also write arrows like this. So you can have an arrow and you'd write H plus because it's acidified potassium dichromate, and you would put down the potassium dichromate. And so this could be used instead of the O with the square brackets. Now for the second example, we have propantool, which is a secondary alcohol, and we're going to oxidize this to propanone, which is a ketone. using acidified potassium dichromate. So what we have is we have propantuol, so CH3, then CH, and this time we have the OH on this carbon, and then a CH3, and then we're going to use this square bracket and the O again, and we're going to form the propanone, so CH3, C double bond O, and then CH3. And we're also going to form water. So this is propanone, and this is propantuol. Now we're going to talk about the reactions of alcohols. So the first one we're going to look at is combustion, and we can undergo complete or incomplete combustion to form carbon dioxide, carbon monoxide, or carbon. And remember that complete combustion is when we have an excess of oxygen, and incomplete combustion is when we have a lack of oxygen. So for example, if we used some ethanol, C2H5OH, which is a liquid, and we combust it with oxygen, and say we want to form carbon dioxide and water. So this would be our complete combustion reaction. Now we would have to balance it. So we've got 2 carbons on the left, so we need 2 on the right. And we have 6 hydrogens on the left, so we need 3 of these waters on the right. And now we have to balance the oxygens. So we have 7 on the right, so that means we need 3 of these oxygens on the left. And so this is our complete combustion equation. Whereas if we were to look at incomplete combustion, so say we started off with ethanol again, and then added some oxygen, and this time we're going to form carbon monoxide, which is a toxic gas, and also some water. And this time, to balance it, we'd need 2 of these carbon monoxides, and then we would need 3 of the waters. But this time, we would only need 2 oxygens. And then we can also form carbon solid, which can lead to global dimming. And water. And now for the balancing of this one, we would need 2 of these carbons, and then 3 waters, but now we only need 1 oxygen. And so these are our equations for incomplete combustion. Now we're going to look at the elimination of water, or it can be called dehydration because we're getting rid of water, in the presence of an acid catalyst. So we can eliminate a water molecule from alcohols by refluxing it with hot concentrated sulfuric acid, or by passing the hot vapor over heated aluminium oxide to form alkenes. So the aluminium oxide would act as a catalyst in that reaction. So for example, if we looked at ethanol, so ethanol has 2 carbons, and then we have the OH and hydrogens everywhere else. And if we added the acid catalyst, so H+, we're going to form ethene. So we've dehydrated it by taking away the water, and then the water comes out, so this is the leaving group, and then the H+ gets regenerated because it's a catalyst. And so we formed ethene from ethanol. And now the third reaction we need to look at is the substitution of halide ions in the presence of an acid. So alcohols, hydrogen halides to form haloalkanes, and the alcohol is heated under reflux with sulfuric acid and a sodium halide, and that's how we form the hydrogen halide. And then this hydrogen halide then reacts with the alcohol to form the haloalkane. So what happens first is, for example, if we have sodium bromide, and then we're going to react this with some sulfuric acid, and this will form sodium hydrogen sulfate, and the hydrogen bromide that we want to react with the alcohol. And then this hydrogen bromide will react with an alcohol, let's say propan-2-ol. So we have 3 carbons and the OH there. And this will form 2-bromopropane. So again, you'll still have the main chain is the same, but this time the bromine has replaced the OH. And so this is why it's a substitution reaction. And then the leaving group is a water, because we've got a H plus here and this OH has left, so they react together to form water. And so the overall equation for this reaction is that we have CH3, CH, OH, CH3 plus NaBr plus H2SO4, and this goes to form this 2-bromopropane, and also sodium hydrogen sulfate and water. So here we have propan-2-ol, and then we have 2-bromopropane. So now we're going to look at some questions. For question 1, pentanal can be oxidized to a carboxylic acid. Write an equation for this reaction and use the square brackets O to represent the oxidizing agent. So what we need to do is we first write down pentanal, so CH3, CH2, 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 CHO. And then we add one of these square brackets O's, and then we form a carboxylic acid. So we should form pentanoic acid from pentanal, because we're oxidizing it. CH2, 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 and then COOH. And then for B, name the carboxylic acid. So this would be pentanoic acid, because it has 5 carbons. And then for C, pentanal can be formed by the oxidation of an alcohol. Identify this alcohol and state the class to which this alcohol belongs. So we know that primary alcohols can be oxidized to pentanal and then to pentanoic acid, so an aldehyde and a carboxylic acid, whereas a secondary alcohol can only be oxidized to a ketone. And so this alcohol must be a primary alcohol. And the reason why secondary alcohols can only be oxidized to ketones is that with a ketone, for example, if we have pentanone, so we have 5 carbons, and then we have a double bond oxygen in the middle. And so these 3 bonds, so the carbon bonds and also the carbon and oxygen bonds, are really, really strong. So it takes a lot of energy to overcome, and so we can't oxidize them any further compared to the carbon hydrogen bonds that we usually are trying to break, which is a lot easier.